now. So we're going to talk about graphing trig functions. One of the main ideas of this entire year of math is learning about a function and then transforming it. So we transform quadratic, exponential, advanced functions, all the different ones, and now we're into trig functions. So I'm going to break it down into sine, cosine, tangent, and then talk about the characteristics of each of those graphs. First, sine. So I just made a chart over here, and I put the parent function as y equals sine of x, and so that's what we're going to graph first. And when we look at it, the thetas, the x value, the theta value is 0, 90, 180, 270, 360. So it's each 90-degree interval around a circle. And when you type them into your calculator, so like all I'm going to do is I'm pressing sine of 0, and that is 0. Sine of 90 degrees, and that's 1. And sine of 180 is 0. Sine of 270 is negative 1, and sine of 360 is 0. Now, the reason this works is because it goes back to the unit circle, which is not something that you need to know in Math 1. If you have questions, I can show you the unit circle, but then I have a graph. I already already graphed it from 1 to negative 1, and then you see my intervals. So 0, 0, 91, 180, 0, 270, negative 1, and 360, 0. And it is a curve like that. So that is just a very quick parent function of sine of x. Now, if I went down to negative 90, negative 180, negative 270, would be a curve the same. But this is the parent function. So some characteristics about the sine function. It is increasing at certain intervals. So from 0 to 90, it's increasing. And then from 270 to 360, it is also increasing. That's how we're going to denote the intervals of increasing. The intervals of increase. The intervals of decrease is going to start decreasing at 90, and it decreases all the way to 270. Now, one little point. This point up here is your maximum. This point down here is your minimum. And then this line in the middle, notice how half of the graph is above it, half of the graph is below it. This line is called, this line, not that dot, but the line is called your midline. And then we're going to talk about complete period in a minute. So it's positive. The intervals of the sine function is positive is from 0 to 180 is positive. And the interval where it's negative, meaning when the y values are negative, mean it's from 180 to 360. Those are your negative intervals. Now let's talk about domain and range. The domain is going to be all real numbers, because you could put any degree value in for the theta, for the x value. But the range, if you notice, it only stays between 1 and negative 1. So our range is between 1 and negative 1. Negative 1 is less than or equal to y is less than or equal to 1. So the range is going to be between 1 and negative 1. Now this word down here, it says amplitude. If you can see it, amplitude. Amplitude is such that how high or low the graph goes. Now, for this parent function, the amplitude is just 1, because it goes up to 1 and down to negative 1. So the amplitude is just 1 for the parent function. We're going to talk about amplitude in a little bit. The period, a complete period, means how long it takes for the function to repeat itself. So for the sine function, for as long as it takes it to get back to this point where it's going to start repeating. So we go up and then down and back here. Now after 360, it would go up and then down again. So this is the complete period, and that would be 360, is when the function repeats itself. So the complete period is that interval or that time frame, how long it takes, not an interval, but how long it takes for the function to repeat. And then if you were asked about intercepts, so you can see the y-intercept is 0, and the x-intercepts are 0, 180, and 360. So there's multiple x-intercepts. Okay? Now, moving on to cosine. All right, so you can copy this down. The cosine function, it's similar. Over here I have my t-chart for x and cosine of x, and all I would do is I would type in cosine of 0, and cosine of 0 is 1. Cosine of 90 degrees is 0. And I could show you, but I already know. I'm going to just write them down. 1, 0, negative 1, 0, 1. So it's going to be still a curve, but it's going to look a little different. Now when I plot that, 0, 1, 90, 0, 180, negative 1, 270, 0, and 360, 1. So I'm curving down, up, there we go. So it still has that curve, but it's in a different point. Instead of seeing from here to here, we're seeing from top to top. So again, we have a minimum value down here. We have a midline, and then we have maximums wherever it goes to the top. So now let's talk about the characteristics of the cosine function. It is increasing starting here, so it's increasing from 180 to 360, it's increasing. And it's decreasing from 0 to 180. So the intervals, it's decreasing and then increasing. It is positive in 2 intervals. It's positive from 0 to 90, and then from 270 to 360. And the function is negative from 90 to 270. So when it's below the x-axis, when it's below 0. The domain of this function, again, is all reals. But the range, again, if you notice, the highest the parent function goes is 1, and the lowest that the parent function goes is negative 1. So negative 1 is less than or equal to y is less than or equal to 1. The amplitude, again, for just the parent cosine function, the amplitude is 1, because you can see from the midline it goes 1 in both directions. And then the complete period, how long does it take for this function to start repeating itself? And so it starts up, it goes down, it comes back up. And then if we continued to go graph it, you would see it would repeat. So again, it's going to be a 360-degree complete period for the cosine function. Okay. Next would be the tangent function. Alright, so you copy these down. Same thing, a t-chart, a graph, and characteristics. Now the tangent function, I put more values in that t-chart, and you'll see why. When you go to your calculator and you type in tangent of 0, it comes out 0. Tangent of 45 is 1. And then when we go to type in tangent of 90, it says error. That's because there is an asymptote every 90 degrees. Well, not every 90. Let me take that back. It's going to sound weird. Every odd multiple of 90, because you got to take out that 0. And so I'll explain it. Every odd multiple of 90. Then I would type in again tangent of 135, and I'm going every 45 degrees. Tangent 180 is 0. Another 45 degrees, tangent of 225 is 1. And then 270 is going to be an asymptote. So when I say an odd multiple of 9, meaning 9, 18, 27, 36, what's the next one? 45. So these are odd multiples of 9. That's when you're going to have an asymptote. I realize that in the hundreds, all of these are even multiples, but I'm talking about without the 0. At 270, 70, at 27, that's going to be a vertical asymptote. At 45, that's going to be a vertical asymptote. At 99, it's a vertical asymptote. So then at 315, we would be down back at -1, and at 360 would be 0. So let me show you what the graph looks like. At 0, 0, and at 45 degrees, so that would be in the middle because this is 90, 180, 270, 360. It would be at 1. But here, there would be a vertical asymptote. And so what the graph looks like is it is curving like that. Now the next section, at 90, there's an asymptote. So at 135, right here, it would be down at -1. At 180, it's at 0. And at 225, it would be back there at +1. So it's curving like this. And then again, I have a vertical asymptote. And at 315, it's at -1. And at 360, I just stopped like that. So I'm just showing you the parent function of tangent. We have the vertical asymptotes in place, and then you can see it's curving up each time in between the vertical asymptotes. Tangent is very special because it's got the unique ratio of opposite over adjacent. So let's look at the characteristics. It is increasing from 0 to 90, from 180 to 270, from just what we're seeing here. It's, well, let me take that back, sorry. It's increasing from 0 to 90. It's also increasing from 90 to 270, and it's increasing from 270 to 360. Although the arrow is pointing down, it still is increasing because we read from left to right. So if I asked you for the slope, this would have a positive slope in that direction. It's not going down. Decreasing would look like this. All right, that would be decreasing. So it's never decreasing. The parent function of a tangent graph is never decreasing. Now it's positive above the x-axis. So 0 to 90, 180 to 270, and then it's negative right here, 90 to 180, and 270 to 360. So the interval from here to here and here to here. The domain, now be careful, the domain of the tangent function is going to be all reals except where you have vertical asymptotes. So except, all reals except asymptotes. And like I said, it's the odd multiples of the 90. The range, now this one's different too because if you look the arrow, this means it goes all the way down to negative infinity and all the way up to positive infinity. So the range is actually all reals. The amplitude of this one, now when you look at it, could you say it definitely goes up or down? No. So we don't have an amplitude. And then the complete period. When do you see it start repeating itself? And if it starts here and it goes up, the next time you see it going up is at 180. So the period for this one is 180 degrees because from here to here it's repeating itself. Or if you looked at the vertical asymptote from 90 to 270, it's going to be 180. Okay? So now let's actually use this and do something with it. So copy this down. The amplitude. If you have an equation of a trig function, sine or cosine, the amplitude is going to be that variable in front, that a value in front, the absolute value of a. So whatever that variable is in front, that's going to be your amplitude. So for example, y equals 3 sine of x. The amplitude is 3 because it's this number. In this one, the amplitude is 4 because remember it's the absolute value of -4. And in this one, the amplitude is 1/3. So that tells us how high or low those curves are going to go. That's the amplitude. If you have a graph, let's say you don't have the equation, if you have a graph, here's how you find the amplitude. You take the maximum and the minimum and you're going to subtract them, divided by 2 in absolute value. Max minus min divided by 2. That's going to show you how to find the amplitude of a function. Alright, so here's an example. I have this is probably a cosine, but I have a function, and I want to know the amplitude. So I'm going to find the maximum is 2, minus the minimum is negative 2, divided by 2. So 2 minus negative 2 is 4. 4 divided by 2 is 2, absolute value, so the amplitude is 2. And you can see because it's 2 above and it's 2 below the midline. So that's just an easy example. Next, midline. The midline cuts the graph in half. So it's like the average. It cuts it horizontally, not vertically, not like the axis of symmetry, but a midline cuts it in half horizontally. And the way you find your midline is you take the max plus the min divided by 2. So it really is the average. You add the 2 divided by 2. So in this example, my max is 2, my minimum is negative 2. So when I add those together, 2 plus negative 2, well, 2 plus negative 2 is 0, and 0 divided by 2 is 0, 0, so the midline is 0, and that means it's this axis right here. The midline is the x-axis. All right, I know this is a lot. So the last slide, all right, I want you to find the amplitude and the midline by using the graph. The amplitude is max minus min divided by 2, and the midline is max plus min divided by 2. And in this equation, these are going by 2. So 2, 4, 6, and this is 90, 180, and 270 if you need it. But these are going by 2s, 2, 4, 6. These are negative 1 and negative 2. And this is right in between. All right, so I want you to try these, and we will go over these in class.